trying to find the where's the
I have been having issues with GitHub. So I don't know if anybody else, but
yeah, me too.
Unicorns, that's what they're blaming it on.
So unfair. Yeah, I had the same thing. I wasn't sure if it was just me. Is this what you see?
Yes.
Yeah,
yes, I see exactly the same.
It's cute.
And Slack has been, I've been having issues with
Slack is having problems all the time now. Yeah, we can't share documents. They're all immediately deleted once they're shared and all this.
Really?
So the internet has trouble as well.
Maybe I'll start.
Anyways, Zoom doesn't have trouble, so we can stop. All right, so today we are going to do another nice tutorial about SPARQL. So as with every week, we've extended our materials slightly. So before we start, I just want to point you to the materials. Obviously, we cannot go through all of the materials as part of this course. I just wanted to give you a bit of an idea of where to find what things. So as you remember, we have this page here, which you can, which is the entry point for our SPARQL materials. This gives you a bunch of tools that are interesting. So I just added a new tool that I've seen, which allows you to actually just point to a turtle file on the web and load that and query that straight away. So that's kind of cool as well. Then we have how do we use SPARQL generally in obo, typical spiel. We've discussed it another time, like a few weeks back, for quality control, generating tables for summary tables, and doing data transformations, and some examples of how this is happening. Now the new things are, so we have extended quite a bit the robot tutorial on quality control. So you should see, so it's called robot tutorial quality control with robot. It has now the proper tutorial where you download an ontology, run some commands. So in particular, I'm going through things like, what are the most important commands for quality control in general. So here we discuss validate profile, which is something that has been historically extremely overlooked, and I bet like most of you don't even know what this does, or actually the other way around. Is there anyone here that knows what the validate profile command does? Just so that I double check my assumption that probably no one uses it, despite its importance. 0 people here know what this command does, and the validate, yeah. So validate profile is a very important thing. I just don't want to discuss it much because it's a bit outside our today's SPARQL tutorial, but because this a lot of what we discuss in SPARQL has to do with QC. So I just want to mention it on the side. It's a command that ensures that our ontology is syntactically valid OWL. So if it is not that, and that's why you should all run to your ontologies and run this command once. This means that anything that the reasoner will do with it may not be giving you the intended results. So the reasoner cannot. The assumption is always that if you run the reasoner, that your ontology must be in syntactically valid DL profile. Anyways, so just for interest reasons, you can also run profile EL, because that gives you a little bit of a hint of that will go through many errors, but this will give you a hint of all the things that ELK is actually missing when it's or many of the things anyways that ELK will be missing when operating with your ontology, just if you're curious about it. In any case, this tutorial will cover this. It will cover robot report, which we will discuss in a bit in a second. Robot verify, which is another robot command that allows us to run SPARQL query to ensure that our ontology is correct, which we will also discuss today. a little bit, and then robot reason, which you all know, as a command to ensure that basically two things. That one, our ontology has no unsatisfiable classes, and two, there are no unintended equivalent classes in it. So this is a very important tutorial for anyone who's interested in quality assurance and quality control, and making sure that the ontology is at the best possible level of quality in any case.
Nico,
Yeah.
could I just ask a really quick question? I was trying to figure out some stuff with the validate DL thing. And it does give me a report, but like I was wondering, is there a better way to? So if I got a report that is just a say not enough operands, and it just spits out a whole thing and doesn't tell me which class it's from and anything, is that something that I'm missing, or is there?
It is hard. You're right. It is a bit hard to interpret, but not enough operand is one of the things it makes sense to really look at. So it's usually where you have like a disjoint axiom where there's only one class inside, or some weird thing like that. But the only way you have, unfortunately, there's nothing I can think of right now so the results may be a bit hard to interpret, and there's nothing other than posting the results in a forum that you can do in order to figure out what they mean. So I don't.
Yeah, I mean, I'm lucky because it was an application ontology, and there's very little terms in there, so I could figure out what's the issue. But I'm like thinking, if I saw this in a big ontology like Ubron, I would have no idea how to find it. So I guess you answered that, and that it's not as simple. Thanks.
It's not as simple, unfortunately. No, sorry. Okay, let's go back to SPARQL. So I also added a little tutorial that you can do in your own time, just tiny, that explains how to just generate a simple table using a SPARQL query with a robot query command, and another tutorial in which we are not going to discuss today, which should be important for example, if Joe is here, but other people also that may be asked to include reports in the context of an ODK setup. So there are some simplifications, like some automations that the ODK takes care of when you're including the reports, which are these TSV files that you're extracting. So basically, if you want, for example, a list of all your classes with the names and the definitions, this is a typical use case, or all the classes in a particular branch, or all the classes that are also connected to genes, or and. So and you want them to extract them as a table, then and if you want to keep doing that all the time and refresh this report all the time, this is how you would fit this report into your ODK setup. This I'm not going to touch it today because it's going a bit too far, but I think I've put the information you need in order to do just that in here. So it's, as you see, it's not a lot. It should be reasonably quickly for you to realize it. All right. So what I was thinking we do today, so I've started putting together like a reference for SPARQL. So I want to go back basically to the very early parts. Let's just go and start from first principles. Do this one time. I know that many of you have already done a lot of SPARQL, and maybe this could be a bit boring, but others are very new to the area. And I would like basically at least once now to go back and really look at the anatomy of a query and really look from first principles, what are the kind of pieces in the SPARQL queries that we keep using frequently across ontologies when we are using them for building QC queries, for example, or for generating reports. And how should we design our SPARQL queries to make them faster and all these kind of stuff. So I just want to focus on this for the next 20 or so minutes, and then you can ask whatever you want. So I'm not looking at the chat. If anyone wants to speak up and ask anything, you have to speak up. Or actually, I will just put the chat on a different screen so that I can see what's up. All right. Okay, so let's go then to do SPARQL from scratch. All right, so the first thing, let's talk about the basic anatomy of a SPARQL query. So a SPARQL query has there are multiple kinds of SPARQL queries. Today we are only concerned with the so-called SPARQL select queries. They are analogous to an SQL select query, and their purpose is to match, to retrieve some data from your ontology and return it to you in some form. Typically, and I think that for now, the easiest way to think about what it returns is a table form. It doesn't have to be a table, but we typically think of it like that. So you can see, let's just start with the very essential here. So you can see here in line 4, this is what we call the select clause. And the select clause essentially just says, here is a list of variables. This is what, so we tell this to the SPARQL engine. So the SPARQL engine is basically the database engine that will compute our SPARQL query. So here we tell the engine, I am interested in whatever you come up with or bind to, like binding, to the term variable and the value variable. Yeah, so select term value. That's what this is. This is what this select clause is saying. The second big part of and this is optional of a SPARQL query is the set of prefix declarations. So here you can see, for example, that we are declaring the prefix RDFS. And why do we do that? We don't have to. So, for example, I could just get rid of this and instead write that. So write it in this syntax here, so you can see the so what I'm asking for here is a description of a triple where the middle part of the triple corresponds to the entity of RDFS label. So this is, I know this is an annotation property. And if I want to just use the entire IRI, so the IRI syntax, we've discussed it in previous times, you all know about this. We talk all the time about the pearls in obo, the term pearls, which are IRIs as well. They need to be wrapped in these pointy brackets. So, and you can see, you look at it and you already start to bleed in your heart because it already looks super ugly. So what people typically do is they define a prefix up top like that. So where you say, please use RDFS as my prefix to describe this IRI namespace here. And then we can just simply simplify this triple to a much more readable form, which looks like this, where you just say RDFS : label. So remember, in the query, like on this prefix-based syntax, you do not need these pointy brackets around. If you want to refer to an entity without specifying any prefix, you always want to put the entities around. Now, another thing that I don't do, but many people do, and I'm starting to think that this is a massively good idea, is to actually go even one step further when you're using your prefixes, because you can put anything in your prefixes and just declare the entire entity as a prefix. So you can do like that, like this. And again, we are saying exactly the same thing as we said before. So before we were using RDFS : label, where RDFS then referred to this namespace. Now we just use label : nothing, which then refers to the entire namespace of, sorry, the entire, let's not call it namespace, the entire entity of label. And this makes these queries even more readable. And for those of you who know the pains of how many of our nice OWL properties look like, for example, this one here, but one moment, I'll show you this here. So this here, I added now a prefix for the definition property. So this is this Perl obo-library.org/IO000115. So here you can just declare this as definition, and you just use. So let's say we also want to get the definitions of the term. I will just deliberately now use a bit of a redundant syntax, but definition. Definition. That's it. So it makes these queries much more readable. Okay, so we have discussed the select clause, we've discussed the prefix clause, and we've started looking a little bit at the third part of the queries, which is the where clause. And the where clause is where all kind of like the magic happens, where we say this is the information we are trying to obtain from our ontology. So here we have a very simple query where we are saying match all the cases, say basically cases to your head, maze out the cases where we have a thing which we call term here. This is the variable name, has a label that is another thing which we would call value. So that's the value variable here. And at the same time have that the same term denoted by the same variable name also has a definition that is definition. Now let's run this for one moment, but I will, just because I don't want to overwork the Uber graph too much here. I'm putting a limit here. This is very useful just to know, to say, okay, SPARQL engine, just look for 10 examples, and after that you stop. So we can look, we can see here, we have a term in the return, we have a term column in the return set and a value column in the return set. But as we see, we do not have a definition in the return set. And that is why, because yes, we haven't added it to the select clause. So we can put the definition here in the select clause, and that will make sure that we get all of this back. But sometimes we just do not want all of the information that we have selected here in the where clause to be shown to us. In fact, many of our queries are simply something like that, where we just get a list of terms based on a particular pattern that we define here as part of the graph query. A useful shortcut in the select clause, the only one I want to say right now is you can use the star operator to just mean return everything about every variable that you have anywhere in the where clause. I would recommend not to use it too much. It's always good to be a bit conservative in what you return, so that you can, control a bit the shape of the output report that you are trying to generate. Okay, so far we've discussed, this is the kind of like basic outline of a query. Obviously, there are thousands of different complex things, and we will discuss some of them in the following. But the basic idea for report generation in OBO, so the process of providing tables, table extracts from our ontologies, is basically you create a query like this. You define the columns in the select clause. You write whatever information you want from the ontology in the where clause, and then you pass this to robot's query to generate a report, or to one of the other commands to generate a quality control check and a report, whatever. Or if you are using YASQI, for example, and UberGraph, you can also just run it like this and just download the report as a TSV file by just clicking on the download button here on the right. But I never do that, so it's not really. So for me, this is really about prototyping the query rather than downloading it, and then I'm always kind of using robots to so if you want to use a different endpoints, so we are using mostly 3 endpoints. I don't even know whether that's the new official one, but I think so. So the Ubergraph endpoint, we use it for most of the things related to UberOnCL, Mondo, Pato, and these kind of ontologies. So you can go to the Uberon site to see what ontologies are loaded. But another thing, an endpoint that you can use is you can go to the ontb SPARQL endpoint, and you can simply use this endpoint here as well to query all OBO ontologies. So Ubergraph only has a small subset. This SPARQL endpoint and ontb, which you can also reference in using the same YAST GUI here. You can put this basically in here, and in place of where I have the Ubergraph endpoint, you can just query all of OBO in using this endpoint here. But for us, there are many advantages of using Ubergraph, which I don't want to go into. It has slightly different shapes, slightly optimized, some optimized queries and stuff like that, but I don't want to go into details about that. Okay, so let's look a little bit about into the where clause. So we have here in the where clause, again, the way that you should think about this is we are creating a graph pattern. I know the first time you hear the sentence, it's like a bit of an annoying phrase to hear someone say that sentence, to create a graph pattern, but eventually this sentence will make a lot of sense once you get a bit more advanced. So the idea is basically you say, you give the SPARQL engine, you tell it like, I want all the triples, let's say, that or look at all the triples that follow this shape. And this shape here I refer to as a graph pattern, basically. And there are a bunch of important syntactic things. So the first thing is usually in the where clause, we are formulating triples. So you see every triple in here is separated by a period operator. This just says, I specified this first triple, I want this to be matched, period, and also at the same time this to be matched. And this is very, very important because some people that first look at this, what they expect to see, so what most people that read this query will expect to see is they will expect to see all the terms in their ontology with their labels and definitions. But this is not exactly what this gives us. What this gives us is all the terms that have a label and have a definition at the same time are going to be shown here. So if a term, for example, doesn't have a definition, this query would miss this term entirely because this term would not match that pattern here. Okay, so if you wanted to make sure that you get for these terms without a query, you can use the first advanced construct here, which is the optional clause. And what the optional clause does to SPARQL, it basically tells it, it has to be the case that the term has a label, but it doesn't necessarily have to be the case that the term has a definition. So let's take a look at this. So you can see in the results here that there are, in fact, a few terms that do not have a definition. So for example, here, these two IAO relationships, they don't have a definition, or they don't come with a definition, but all of them must have a label. So that is what this optional query does. So it's very important to keep in mind that stitching these triples together really means all of them must be true at the same time. Another thing that people need to wrap their head around when they are writing these triple patterns is that they can be split in different ways. So one is just to use these, like you can basically just use always a triple with a dot in the middle, but you can also stitch two triples together by, by using a semicolon and just say, let me just copy this back out here. By using a semicolon and saying basically by that, keep the subject of the triple and just add another property, another predicate and object of the triplet. So here, this here is exactly the same as if you, when you say that, if you say period term. I don't think that there is internally any difference between these two expressions, so they're just synonymous with each other. Okay, so so this is just two different ways to stitch triplets together. Now, one of the things that we do a lot when we are building tables. So, for example, we look at this table and we say, "Oh, we don't really care about most of the stuff because we only care about the properties in our own ontology." Is we ask, we have to write a filter expression that that gets us a subset of the terms that we are really interested in. This now here looked at an endpoint and gave us all of the terms that this endpoint has to offer, but we only care about CL terms. So here we are starting to think think a bit more advanced, because I will mention a few things about like speed as well, because one of the big issues as a SPARQL query developer that you will be faced with is for many things in SPARQL that is related to OWL in particular, SPARQL is terrible. Like, it's a very, very bad language for writing some of the very complex OWL class expressions if you have to match them, and you will be like bleeding over some of the patterns you will have to represent in these queries, because they're really, really cognitively complex. So it's always good to have example queries stored that you can just copy paste together. But the other thing is that SPARQL is very, very difficult to optimize. So you don't have this thing like in SQL where you can just put an index on something and it's and thereby making a query to something specific very fast. So if I do a filter, for example, like this, so I'm just doing a simple filter now, where I look for all of the terms that start with that are from CL. So let me just do it like this. Still starts. That's right. So so you can see what this filter does is it looks at the term and checks whether the term, if you were to look at it as a string, so this is one of the very confusing things in the beginning, you nearly always have to use this str function around the variables if you want to do any kind of string operations like concatenation, replacement, and also matching like this here. So just keep in mind, you always need this. So this is just looking for, this is just applying a filter that looks at all the terms, and then after the fact checks whether the term starts with this IRI pattern here. So basically CL. Now there's something like that you need to consider when you are writing such a filter. So the first thing is that these filter expressions are always executed after you've already after the query engine already did the hard job of matching whatever you have done in this part before. So when you are thinking in your mind when you're writing a filter query, do not think that because you've put a filter here you have made less work for your SPARQL query engine. In fact, it will still have to go through the entire database, and then for each match of whatever you see up here, like for each match where you have a term with a label and a value, it needs to check separately that this term IRI starts with CL. Now you can add many different kinds of filters, so you can concatenate them with ampersand syntax if you wanted to do that. But you can also just have multiple filter clauses right after each other. So one typical one that you will see very often is the is-iri filter. It's slightly redundant here now, but doesn't matter. So this just makes sure that that whatever we are querying, that this variable is not bound to what we call an anonymous node. So an anonymous node, I will answer this if someone asks what this is, but it's basically something, it's basically an object in RDF that does not have an IRI. So this is a typical other filter that you can apply. All right, so so I just want to show you one alternative thing here, which many people do, and it can cause a lot of issues. So what happens technically, and actually I'm asking this to someone like someone here. So this here, all right. Can someone here speak up that doesn't know SPARQL like Anita, but someone else? Can someone speak up and make a hypothesis of what? So why? So first of all, the first question I have is, does this do the same? Where so basically I replaced the RDFS label property in the middle of this triple here with a variable, and then I just add the variable in the filter to say check whether the property is a label. So my question to you is, do you think that this gives us the same results? A, and B, what may be wrong with this, or what may not be wrong with it, but not maybe a problem with that?
Is this less efficient to do it that way, since it's already running the larger query and then filtering after the fact?
That's exactly right. Yes. So that is exactly, and I think it seems like something advanced to start to learn this stuff, but it's a very important concept to get into your minds. Is exactly how you're saying. So what happens here is this where clause basically matches every single possible triple in the entire triple store. So if I wouldn't put a limit, this query would definitely time out. So it would just stop working because it would have to load the entire triple store and match everything. And then after it's done that, it will go and weed out those triples that do not apply to this particular property. Now, what is interesting, and here this is one thing, and that's why I want to convey this, is in some cases, and especially when we are dealing with synonyms. So let me just quickly find a synonym. Let's say this one here. Where are we? There you go. So, and I don't know what happened to my query. I must have accidentally. Oh no, here it is. In some cases, what we want to do is we want to match, let's say, any synonym. And as some of you know, there are multiple ways to describe synonyms. For example, exact synonym, close synonyms, and so on. And in these cases, what you want to do is you want to be able to keep this here a variable, so the property in this triple statement a variable, but you want to say that it should either be an exact synonym, a broad synonym, or an error synonym. Many people that start developing SPARQL queries will go and say, okay, let's just use a filter. So you use this property box, and then you will say in your filter, in your filter, you can say, is a property an exact synonym, or is it a broad synonym, or is it an error synonym? But the way that you should actually do this is using another construct, which is called values. synonym. I'll just okay, so now let's run this as an example here. So what happens here now? Instead, so I've seen many people putting these into filter queries, which means, again, you have to run through the entire triple, so you have to query everything and then filter after the fact. Now, if you do it like this, if you use a values construct, you basically tell the SPARQL engine to query only for one of the properties that are specified by this value statement, which means that it's only doing it beforehand. And thinking about before and after is really important when you're thinking about making these queries fast enough for your use cases. And in this case, it will resolve these synonyms, bind them before it's executing the queries. And this means that if you're running something like this, it will be very, very fast. So think the less in filter, the least that you can put in filter as possible, the more you can put into the where clause up top, the better. So it's SPARQL query optimization is the art of reducing the SPARQL query to the fastest possible, so to the smallest possible matching graph pattern, basically. And sometimes it can even help to add something like a subclass of axiom that into your. So, for example, I noticed that that you can speed up this query here massively by simply adding a separate statement in here like this, where you say the term must be an RDF subclass of to just write this down to know now what the syntax for the cell is, but let's just assume it's 1, 2, 3, 4, 5, 6, 7. So it will be massively sped up if you can add a statement like this that reduces the search space for the query engine, that now only looks at terms that are subclasses of the CL terms and doesn't have to look to every term whether it starts with CL. So keep this in mind when you are working on query optimization. All right, let's make a small intersection here. Do you have any questions so far? Otherwise, we will now quickly advance to more lofty heights with more aggregation and more operators. Yeah, so here what Joe is Joe is asking in the chat about so you're saying more variables inside one filter.
Yeah, like you can delimit, you can have several filters, like you have a single filter statement, and then you could have the double ampersand to put multiple filters inside it. But I was getting an error if I was trying to filter two variables within like a single filter clause. And I could only fix the error by splitting it up into multiple filter clauses for different variables.
Yeah, so I think that I wasn't even aware. So I always split the filters just for readability reasons when they are pertaining to different entities. I didn't even know that there was a restriction that says, but it makes some sense to have that restriction, to be honest. So I didn't, but yeah, let's just try it here. Actually, I don't need still here, I think. Value. So here it seems to be fine with it. So I don't know. Maybe this is dependent on the query engine you're using. So it seems, so this here I think is the same as if you were to split this into two separate filters. I don't know whether there's any optimization advantage over one syntax and the other, but I doubt it. So yeah, I would just split the filters for now. Okay.
Nico,
Yeah, go ahead.
can you do null or empty value or empty label, empty property, I guess is the right word, in the where clause instead of the filter clause?
You mean so that where this is a null, like I
Yeah.
don't know what this would mean. So there's you
Where
mean like you have
like changing. So what I understood was that like the filter bits are really slow. And so Joe put this
Yeah.
big filter statement into the chat. And it seems like
Yeah.
you already answered the question of how you do the Mondo filter he has in a subclass of statement there, like you have with CL. But then I was thinking, well, how do you find where all the terms that have blank xrefs? And if we want to take it out of the filter class, how do you put that in the where clause or in the top value section of the query?
So when you mean what you mean by a blank xref is like, is there no xref attached to the term?
Correct. Yeah.
Or okay, so that's that let's discuss this for a second, because that's something entirely that's something very different. So so I'm just repurposing this this definition statement here. So there's another construct, again very costly computationally, that what it does is it will check whether it will make sure that a triple is not true. So for example, here in what so for the example that Tierra just was asking for, it could be just xref instead of definitions. But what it would check is it would match all of the CL terms that do not have a synonym but no definition, and actually start with SP, because that's another filter we put in there, and there's just one that fulfills this, and you can see also by the fact that there's no definition in the end that this is true. So this is how you check whether there is no triple attached, no particular triple attached to this class. Now, if you were asking something slightly different, which is looking for definitions that are just empty strings, that would be something else. You can do this kind of thing, and in fact, we do quite often do this when we are looking. So we have this. Almost all of our queries have a check whether the class is obsolete or not. So let me just dig out one. This one here. So here you can see yeah, sorry. Okay. I don't know why it's complaining with right now, but because XST is not in the namespace. Sorry, XST. All right. So here you can see. So some people try to deal with things where you have like literal values at the end of properties by using again filter, but here we have a slight problem in SPARQL, which is super annoying. In the case of OWL deprecated, we are quite well standardized, so we can assume that all of our obsolete classes actually are formatted exactly in this particular fashion, and so we can put the literal value for our query straight into the where part of the of our query, so it's or into the triple pattern, let's say. Now, if you have like, let's say, labels, let me just remove this and see whether there is one straightforward example that we can just see here. Nope. Labels are very often formatted in very different ways. So sometimes they have like a language tag attached with it, like an @en attached with it, or they are sometimes typed as something slightly different. And then in this case, you cannot just write something like that, because this here will not. So if you're using a string true, this will not match string true with an @en English tag attached with it. So in this kind of case, you unfortunately you have to use filter string. So you would have a value here again, and you would check whether this value is equal to the string, or value of this value is equal to true. So that's an unfortunate side effect. All right. So this is in any case, yeah. Go ahead.
Oh, just saying thanks. Yep.
Yeah. Okay, so this is the filter not exists, which you will also frequently use for many things, and the most used filter not exist that we usually have is we do not want to include obsolete classes in our query, so we use this this filter not exist clause in here, but there are also many other use cases. All right, so from here, let me take a look at the time. Let's just, so that, because I want to be sure that I address any kind of pressing questions that people wanted to bring up in the SPARQL call in general. So even if it's slightly beyond and above what we've discussed here, did anyone bring any particular SPARQL related questions here today that they want to go through together?
Just a really simple, probably I'm stupid kind of question. So if say I want everything that is not starting with that CL Perl, do I put the exclamation mark at the string start, or is that just that?
Yeah. So
All
if
right,
you do
great.
that, this also shows that they're interesting. Anyways, so I would have expected no results now, because we still have the subclass of CL00, but there seem to be a bunch of cell types in EFO. And look, EFO doesn't use the same rigorous QC that we usually use. There's some white space in this label as well. Yeah, so you can just use the not operator on the filter to negate it and look for everything that does not start with the CL. And also for also another point for optimization. So for the past 3 years, I've been using this syntax here that Joe also shared before, like regex, which in this case here will even will show the exact same results, but Jim had to educate me that actually regex matching is way more costly than using something simple structural like starts, which is a function that literally just makes sure that the string starts with this particular set of characters. So regex is again something that should be avoided for. Yeah, we can discuss. This is an interesting question actually. If anyone has questions about SQL versus SPARQL, and in particular then we can go through that. I didn't even look who's here, so don't know who's here. So is there any SPARQL way to try and retrieve the name of the root without knowing it in advance? It's a very good question, Harry, and let's just try to answer it. Answer someone else. Let you try to answer it actually. So let's just how would we go about something like that? So first of all, let's think about the definition of root. So what is a root?
So if we can filter it to something that is not a subclass.
Mm-hmm. Let's do that exact thing. Like let's just work our way through slowly. So I will just enter this. I'll just assume we are looking for classes just to speed some things up a little bit. Okay, so all right, what do we do? So if that something that is not a subclass, as you say, so how would you solve this? How would you think about it? All of the constructs that we've discussed them in the last minutes. So we look for all the classes, and then what do we look for?
So it's not going to be in the OWL subclass of. So I really want to use a filter on this. So yeah, I could say filter not exists term OWL subclass of.
That's right. Yeah, that's how you start exactly. That's the first step as well. So you want to know, you want to make sure that there's no statement subclass of.
Or yeah, it's an RDF. Yeah, not part of the OWL.
Yeah. So let's take a look at that. There will be oh yeah, this is very costly. So let's not look at that maybe. So I can tell you already. So one thing that is slightly problematic with this, let's just get rid of this filter here because that is what's making it so slow. So let's just put a limit 1. Hopefully that would, and maybe let's get rid of the filter not exist clause here as well. No, it's too slow for Ubergraph, unfortunately. It needs to look through too many things, but the approach is exactly right. So what you would do is, so first of all, there are 2 ways in ontologies that you can look for root terms. The first one is exactly as you say, look for everything that doesn't have a parent, and this is how you would do it. So this would be the parent class. And the second thing that you can do is there's this property which is IAO 700 that you can use to select. So all of our ontologies have IAO 700 to denote this is a root term. This is actually a better way probably to find the roots of the ontologies that you care about. So you could write something like this. I'll just make this root property here, IAO 700, and let's say, so this is actually a bit strange syntax now, but don't worry about it. Ontology root term. Okay, so this gives no result for some reason, but because I wrote a 5 here. So you can see now you get the CL class that we're looking for. I can even, this is super fast, so I would just ask for 10. These are all our root classes, and now you can just apply filter on top of it. This is so this is a good practice for all our ontologies. Always declare your root classes in your ontology using the IAO 700 code.
Great, thanks.
What else? No, wait, no. What else came up in terms of questions? Yeah. So one of the big differences, I think, with between, so SQL is like 1,000,000 times better in terms of, looking, these filter syntaxes in SPARQL are horrible. But one thing that is quite cool with SPARQL is the fact that you actually do not have to worry about joins. So what do I mean by that? In Ubergraph, you have to not worry about that in any case. But just got to move rid of this again. So if I wanted to get all the children of so if I wanted to get all the children of a term, then this would be a quite, I mean, nowadays there are probably like many pretty advanced SPARQL query and SQL query engine, and there is like a construct which is called recursive SPARQL that you could use to do something like that. But obviously, this is the kind of queries where SPARQL shines a lot. So you can say rather than having to do some kind of table joins where you keep joining and joining and joining recursively the tables together, you can say, give me all the children of the term which are one or more subclass of hops away from the term. That's I would say the biggest difference probably, and the biggest selling point of SPARQL. And otherwise, SQL is probably superior in almost every other fashion that you can think about. But that is the big selling point, I think, for a graph kind of based query language. Do you have any other opinion about this, Chris? Do you think that there's other selling points for SPARQL over SQL?
Yeah, it's a bit of a big open-ended question for 1 minute left on the call, but I think there's definitely cultural things I really like about SPARQL. Like there's a culture, it's kind of built into the technology specs to some extent as well, of just making open endpoints. I wish people do this with SQL endpoints, but it's not very common. People don't make use of them, and it's just not part of the culture. And when they, and I like the fact that things in SPARQL are kind of in some ways more introspectable, but in some ways it's a bit harder actually, you know, to kind of like get a sense of what the structure of the schema is. But you know, there's just the general advantages of RDF, that everything has a URI. So if you want to kind of find out more about it, you can just kind of like follow the link and so on. So but yeah, I mean, as from a computer science point of view, at the end of the day, they're not radically different, really. Yeah, the syntax of SPARQL is definitely nicer than writing kind of very explicit joins, but what it does under the hood is maybe not, to me anyway, radically different. But others may disagree to some extent there.
Yeah. So the argument of endpoints is a good one as well. So one cool thing that we could discuss at some point is actually that you can combine different endpoints together in the same SPARQL query. So you can say, get us some information from the ubergraph endpoint and combine it with some information from the Campbell endpoint, and then give us a joint result over these two endpoints. So some stuff like that is also something that we can at some point look at. But to be honest, in the 5 years that we've been working here, we haven't ever done that. So while we were looking at the endpoints singularly a lot. Good, time's up. Thank you very much for that. Nicole, we need to organize the next tutorial. I think that we just do this in our next meeting. And
Sure.
if there are any particular wishes from the group here, just put them forward. So we didn't hear from you anything about what you want to do next. I would suggest we do something more curation based again. But it's your time, your hour, your tutorial. So you make the proposals and just let us know whatever you want to be taught, and we will make sure that it's done. All right. See you guys later.
Thank you.
Thanks,
everyone.
Nico. Bye, everyone. See you next time.
Bye.
Thanks.